Welcome. In this video we will see how to find the area of the circle x square plus y square equal to a square using double integrals. We will have to quickly recap that. The formula for area in Cartesian coordinates using double integrals is given by double integral dx dy. The value of the function f of x comma y is taken as 1 when we estimate the area. So the formula for area is, recollect, double integral dx dy. Now we are going to find the area of the circle x square plus y square equal to a square. Let us first plot it. So we have our x-axis, the y-axis, and then the circle. So the circle is given by x square plus y square equal to a square. This circle has center with 0, 0 and it has radius as a units, which means whichever direction you move from the center to the boundary, the distance measured is always a units. Now we are going to fix the limits. Now the problem can be handled in a better way by use of symmetry. What do we mean by symmetry? Something that is going to be a mirror image of the other portion is called as symmetry. We see that this circle can be divided into 4 parts: 1, 2, 3, 4, and by symmetry all the 4 of them are going to be identical. So instead of evaluating the area for the entire of the circle, what I am going to do is I am going to find the area to be equal to 4 times of the quantity in the first quadrant alone. So what is the first quadrant? The axis, which is going to be your y-axis given as x equal to 0, the x-axis which is given as y equal to 0, and this curve which is x square plus y square equal to a square. So I am going to just evaluate for one portion of it, and then I am going to multiply it with 4. So that is equivalent to finding the entire area of the circle. Now coming to this portion where I am going to evaluate in the first quadrant, the sectors, what are going to be the boundary of it? The boundaries are going to be my axis, which is given as x equal to 0, y equal to 0, and now the curve. The curve is given by x square plus y square equal to a square. So what are these boundary points? The origin 0, 0. This point is 0 and we know that the radius is going to be a units. So this becomes a, 0, and this point again is going to be a units and x is going to be 0. So 0, a. So these are my boundary values and boundary points. Now how to find the limit for integration? I know the formula for area is double integral dx dy. Now I need to fix the limit for x and the limit for y. This can be done by 2 ways, as we have already seen, either in the direction of x or in the direction of y. Now for this problem I am going to solve it in the direction of x, in the direction of x-axis. So if I want to solve the problem in the direction of x-axis, then what is the rule? Then we need to draw a strip which is parallel to your x-axis, And what is the direction of movement? The direction of movement is from left to right. So we are now ready to fix the limits. Draw a strip from left to right in the direction of your x-axis. So now this becomes the leftmost value and this becomes the rightmost value as we move in the direction of x. Hence, we can fix the limit as the lower limit for x begins the journey with 0 and x moves till the upper end, which is going to be the curve. What is the curve? X square plus y square equal to a square. So what is x square? X square is a square minus y square. So what will be x from over here? It will be plus or minus root over a square minus y square. Now x has two values, one is positive and the other one is negative. So the positive values lies in the first quadrant and the negative values lies in the fourth quadrant. But since we are taking only the first quadrant into evaluation, we ignore the negative sign and just take the positive quantity alone. So where does our x move now? From the leftmost region 0 to the rightmost region, which is governed by positive root over a square minus y square. So our limit of x is fixed now. Now what happens? I need to fix the limit for y. If first limit is going to be variable in nature, then the second limit is going to be constant. How to fix the constant limit in the direction of y? Y moves from bottom to top. So now check for the y coordinate. What is the lower limit for your y? Lower limit for y begins with 0. What is the upper limit for y? This is the maximum value my y can move to. It moves till the point called as a, because a is the radius of the circle. So the limit for y takes the values between 0 to a and limit x takes the values between 0 to root over a square minus y square. What is the function which you will have to evaluate? The function to be evaluated is 1, and now the integration is done with respect to dx and then with respect to dy. We'll move to the next slide. We will have to evaluate area, which is given by 1/4 of the quadrant varying between 0 to a and x varying between 0 to root over a square minus y square, a dx, a dy. Now recollect, integral dx is given by x. So whenever integrate, the order of integration is from inside to outside. What gets evaluated first? The value which gets evaluated first is the inner portion. So this portion, which is going to be integral 0 to root over a square minus y square, dx get evaluated first. So what is integral dx? Integral dx is x. And what is the limit we need to apply to it? Root over a square minus y square to 0. And the second limit, which is y to 0 and y equal to a, remains as such. When we apply the upper limit, what happens to the upper limit? We have y to be still fixed between 0 to a. Upper limit is root over a square minus y square. And what is the lower limit? Lower limit becomes 0 and the integration has to be carried out with respect to y. Now we have it of the format root over a square minus y square dy. We need to recollect the formula which we learnt in our lower grades, like root over a square minus x square dx is equal to x by 2 root over a square minus x square plus a square by 2 sine inverse x by a. Now this is the formula we need to keep in mind to solve this portion. Okay, applying the formula, replacing the variable x with that of y, what we have is, we have this quantity to be evaluated as y by 2 root over a square minus y square plus a square by 2 sine inverse y by a. This has to be now applied between the limits a to 0. Let us apply the upper limit y equal to a. When y happens to be equal to a, you will have a square minus a square to be equal to 0. So, the first term vanishes, giving you 0. Let us move to the second term. I have a square by 2 sine inverse of y takes the value a. A by a makes it as 1. Next, let us move to the lower limit 0 minus, so this is upper limit minus the lower limit. So what is the lower limit? Y takes the value 0. So it is 0 times of something, which is 0. And next, when this y takes the value 0, we need to know that sine inverse of 0 is going to be 0. So there will be no lower limit existing. Only one term of the portion exists, which is a square by 2 sine inverse of 1. Now, what is sine inverse of 1? That is the angle for which sine reaches the value 1. When the sine reaches the value 1, it reaches at 90 degree. So, sine inverse of 1 will be equal to pi by 2. So, the area for one portion of the integral will be pi a square by 4. But what is our requisite? Our requisite is 4 times of the first quadrant. What is this first quadrant? Obtained as pi a square by 4. So when I want the total area, the area is 4 times of pi a square by 4. So this 4 and 4 cancels off, leaving you with pi a square units as your area of integration. So the area of the circle as obtained using double integrals is pi a square units.